Dear students, I welcome you to NEET World. So considering upcoming NEET and EAPCET entrance exams, so we have started discussion of NEET previous year questions as well as EAPCET previous year questions. So as of now we will be starting NEET PYQ session. I mean this session is purely for previous year questions of NEET exam. Okay. So in this session I will be discussing complete previous year questions of 2019 NEET exam. Okay. So this is related to chemistry part, right? So already we have done with botany and zoology. So now we are doing about like with the chemistry part. Okay. So if you want to access this question paper, complete questions like zoology, botany, chemistry and physics. So you just go through the link provided below where you have a link for the app, NEET World app. So download the app. So there you can access complete PDF of this previous year questions from 2019 to 2024. So you can access all these question papers and you can also practice those. Okay. So as of now, look into this session. So where I will be clearly explaining all the PYQs. Yes. So at the last moment, you know everyone. So at the last moment, we need to focus more on problem solving, like what kind of questions they are asking, and we need to focus from where the questions are asking majorly, and we also need to maintain our time sense, right? So what are the things we need to follow during our examination time? I mean we need to give some mock test. Okay, so you can also practice some previous year questions only, and you have to revise your short notes that you have prepared previous from last few days, right? Like for every chapter you need to have a particular short notebook. So where you have to be filled with only that short notes should contain only like important formulas and important statements, all those things that will be highly helpful at this last minute preparation. Okay, so let us start our discussion of this 2019 question paper. This is what 2019 question paper, and here I am starting with our chemistry part. Yes, look into this. The structure of intermediate A in the following reaction is. So this is the reaction given. So just confirm me whether my voice is clear or not. Yes. So here the given thing is the given alkene. So here alkyl benzene, alkyl benzene is given. So this particular molecule, like substrate, we should call it as cumene. What is that? Cumene. So from using the cumene, upon oxidation it will form an intermediate A here. So upon hydrolysis, acidic hydrolysis gives phenol as a product. This is one of the most important question, and it was seen in many exams like JEE, NEET and EAPCET. Okay, and repeatedly asking question this is. So what happens here is this cumene, the cumene is there now here. So it will be having a structure like this. So CH3, CH3. Now when we are treating with oxygen, so what happens is this oxygen, here we have oxygen like this. So this oxygen will oxidizes this molecule and it will convert into this form. We will be getting a peroxy linkage here like this, OOH. So this is a compound A formed. This compound upon treating with water in acidic medium, okay, gives phenol as a product here, gives what? Phenol as a product, and the remaining part, look here, this remaining carbon part is there now, so that will forms acetone here. So totally we are getting phenol and acetone as a products. Okay, you have to remember this. So what is the A formed here? So this is a cumene hydroperoxide, we can say. So like this, where do we have? We have option 2. So option 2 is correct for this particular question. I hope it is clear, there is no confusion, right? Okay. Now, yeah, so you need to focus again. What are the steps? Cumene is getting oxidized to cumene hydroperoxide. So this is what? Cumene. Okay, this time they may ask what are the products formed during this reaction. Okay, one is acetone and another one is phenol. So you have to revise this kind of important topics. Okay, now number of sigma and pi bonds in this particular compound they are asking. Okay, how do we write pent? So write 5 carbons. Okay, so whatever the concept you know, apply that to answer this kind of questions. See, pent 2 in, so let us put a double bond here. Okay, so they are saying 4 ine, so whatever it is, just take this is 1, 2, 3, 4, 5. So if it is 5, so we can write a triple bond here because they are saying ine. So triple bond. Now count number of sigma and pi bonds. So after writing like this, so just write in the proper manner here. We have CH3 here and here double bond means on this carbon. So all carbons should be satisfied with their valency. Like tetravalency should be satisfied for each of these carbons. Like this you can make. Okay, here also we have like this. Okay, now count number of sigma bonds. Here 3 hydrogens attached to the carbon means 3 sigma bonds here, 4th sigma, 5 sigma, and here 6 sigma, 7, 8, and here 9, this is 10. So 10 sigma bonds, yes. Now how many pi bonds? This is 1 pi, this is second one, this is third one. So total 10 sigma and 3 pi bonds are there. So 10 sigma, 3 pi bonds. So first option is correct. I hope it is clear, there is no confusion here, right? Okay. So let us move forward with some more important and interesting questions here. Yes. So this is also one of the important question here. So now I will be asking you, so I will be explaining the structure and answer for this. So but I will be asking you what is the average oxidation state, average oxidation state of bromine. What is the average oxidation state of bromine in this Br3O8 structure? In Br3O8 molecule, what is the average oxidation state of bromine? So this question is from redox reactions. I have created this question from redox reactions. Okay, so you have to mention question number 48 in the comment box and answer the question for this question. So I will be explaining particular structure here. So when it is given as tribromo octa oxide, so it means 3 bromines are there. Yes. Okay, we know for each bromine it has it can form 7 bonds, right? Maximum it can form 7 bonds. No. Okay, now okay, so I will be explaining the answer for this average oxidation state also directly. How can we take? So from bromine, let us consider X. How many bromines are there? 3 bromines, so 3x plus oxygens are 8 are there. Each oxygen will be -2 oxidation state. So overall molecule is neutral, so I am taking it as 0. So 3x will be equals to plus 16, x will be 16 by 3. So this is the average oxidation state we can say. Okay, so if someone asks you for average oxidation state, you have to find it like this. Okay, if they ask for individual oxidation state, that can be given from its structure only by looking how many oxygens are surrounded around that particular bromine atom. So you can give individual oxidation from its structure. Okay, now the structure will be, see, it will be like this, like this, like this, like this. Okay, there is direct bond, like Br direct bond will be there. Okay, so here also like this, like this. So for surrounding, like terminal bromines, 6 bonds here, 7th bond here. For this side also 7 bonds are over. But for the central one, look here, this side 1 bond, this side another bond, 2 bonds over, and this is 4 bonds over, 5, 6 bonds over. It means there is one more valency electrons on this bromine. Yes. So I can say this is the structure of this tribromo octa oxide. This is the structure of like Br3O8. And if someone asks you what is the magnetic nature of this particular molecule, you should say it as paramagnetic. Why you should say paramagnetic? See here, one unpaired electron is there. So this won't be highlighted anywhere, but you should think of this because there is one unpaired electron, where it went. So it is not mentioned anywhere, but you should think of it. They ask you what is the magnetic nature, you can say paramagnetic because it is having one unpaired electron. Okay, this is about the Br3O8. See, I am not just covering PYQs, I am also showing you the path, how to put the interest or how to analyze the important concepts, right? So this is what they require at this moment. So you need to solve the PYQs. You can also need to study the complete atmosphere, complete environment, like what are the questions we can expect in the upcoming exam from this particular topic. So this is how you need to analyze the topics when you are going for a exam. Okay, so I hope it is clear. So this is a structure, it means first option is correct here also. And sir, how can you saying that there is directly Br bond, why not it is like BRO Br bond? So why it won't be like this? So this is completely depends upon its oxidation state. So when you are calculating average oxidation state, if it is, see, if we are doing this, it will be around some 5.1, right, 5.3. So average oxidation state, if we exactly if I calculate, it will be around 5.3. So always remember, for halogens, particularly for bromine, the maximum oxidation state it can exhibit is +7. How much? It can lose all the 7 electrons from the bromine atom, valency 7 electrons, and it can exhibit +7. But here what is the oxidation state we got? It is 5.3, which is lesser than its maximum oxidation state. So whenever we are drawing a structure, so during the writing the structure, so if the calculated oxidation state, this average oxidation state is less than their maximum oxidation state, so you can directly write the direct Br bonds, like directly center atoms to central atom bond you can directly write. Whenever it is equals to maximum oxidation state, if this average oxidation state is equals to maximum oxidation state, in that case you have to write oxy bond. Like for example, atom M is there, it is having now it's having average oxidation state equals to its maximum oxidation state, then you have to write MOM type bond. If it is equals to 7, we have to write BRO-BR type of bond. I hope it is clear, there is no confusion at all, right? So since the calculated average oxidation state is less than the maximum oxidation state of bromine, that's why I am writing direct BR-BR linkage instead of BRO-BR linkage. I hope it is clear, no confusions. Okay. Now I hope it is clear, and also these are the things you should focus from this particular topic. Then next, yes, this is a common question we can see in NEET and EAPCET and JEE kind of exams. See, like we have provided with 4 different orbitals. They have provided 4d, 5p and 5f, 6p. So these are the orbitals provided, and they are asking arrange them in the decreasing order of energies. How can we arrange them decreasing order of their energies? So here, how can we identify? So just take for, see, whenever we are saying energy order for orbitals, you have to take n plus L rule. What I am saying n plus L rule gives the energy order of the orbitals. Okay, for this is for multi-electron system. See, if the electrons are more than 1, then we have to follow this rule. If only single electron is there, just follow the rule, that is n. Higher the n value, higher is the energy. That valid for single electron system. And here we are saying, here it is not mentioned whether multi or single, so you can consider it as multi-electron, and you have to take n plus L rule. If n plus L rule is same, follow higher n value, higher will be the energy. What I told you, first rule is n plus L rule you have to take. If the n plus L values are same for different orbitals, then follow higher the n value, higher is its energy. Yes, look at here. The n value is nothing but the coefficient here, the principal quantum number which is mentioned there. Okay, that is the n value, like ns they will give, np they will give. So here 4d is given, 4 is the principal quantum number here, n value is 4. Okay, now we know L value for s orbital is 0. Okay, and p orbital is 1, for d it is 2, for f it is 3. If something like g is there, that will become 4. Okay, I hope it is clear. Now here it is given as 4d, so n value is 4 mentioned here, and what about for d, L value is what? 2, so it means L is 2, so overall how much? 4 plus 2, so n plus L value we have to take now 4 plus 2, this is 6. So higher the n plus value, n plus L value, higher is its energy. For 5p it will be 5 plus, for p it is 1, so consider it as 6. Okay, for this how can we write? For 5 plus f means it is 3, so we can say it is 8. For 6p means 6 plus 1, this is 7. So arrange them based on their increasing order. So they are asking about decreasing order. So highest is for 5f, because highest n plus L value, so highest energy is for 5f. Then next, here 7 is there for 6p, so write 6p here. Okay, then what I told you, here 6 and here also 6. So when n plus L values are same, this is the first rule. What is the second priority rule I told you? Higher the n value, higher is its energy. Here n value is 5, here n value is 4, which is higher number? this 5 is higher na, so this 5p is having higher energy than the 4d. This is how you need to answer the questions. Just look, this kind of option will be there. See, 5f, 6p, 5p, 4d. So option 1 is correct. I hope it is clear. There is no confusion, right? Okay. So you have to focus on this like quantum numbers. So where you need to focus? Quantum number topic you have to check once, because from quantum number there will be at least one question we can expect. Definitely there will be one question, either it is NEET or EAPCET exam. Okay. So if you want to study, if you want a clear cut explanation of quantum numbers, write in the comment box about quantum numbers. Just write it as quantum numbers. Therefore I will be considering it for next session. Okay. Now here consider which of the following reactions are disproportionation reactions. So whenever they are saying disproportionation, for example, a metal M is there, one species, like let us say element M is there. If I saying it is undergoing disproportionation reactions, so this element should undergo oxidation and the same element should undergo reduction. So if the same element undergoing oxidation, reduction in a particular reaction, then we can say that process as disproportionation reaction. So same element M should undergo oxidation like this, some oxidation state N. So again this should undergo some reduction like this, like M or N, something like this it should happen. Okay. Look here, here copper is having +1 state, it is converted into +2. So what is this process? Loss of electron, oxidation. Okay. From here to here it is, see, +1 becoming 0, number is reduced. So this is what? Reduction. So I can say this is following redox reaction, that is what? This is a example of disproportionation reaction. Similarly, here you can calculate MnO for 2 minus. So how can we calculate the oxidation state for that? Look here. Look here. So for Mn, manganese you can say X. For manganese you can say X. For how many oxygen atoms are there? 4 are there. So each one is -2 equals to overall charge is -2, like this. So X will be -2 plus 8. X will be +6. So this is how we need to calculate the oxidation state. This +6 is converting into MnO4 minus, that is what? Permanganate ion. So here oxidation state is +7. Okay. Here it is MnO2. This is +4. So +6 is, see, +6 becoming +7. Number is increased. This process is called oxidation. Here +6 is converting into +4. Number is decreased. That process is what? Reduction. So this is also same element undergoing oxidation as well as reduction. So I can say this is also disproportionation reaction. I hope it is clear. Next, here +7 oxidation state. So remember, if any element, let us say manganese, the maximum oxidation state is +7. If any element it is in its maximum oxidation state, that won't show disproportionation reaction, because it is not possible to undergo oxidation now, because already it is in maximum oxidation state. Therefore here already manganese in +7 oxidation state, there is no chance for undergoing oxidation again, because it is already reached its maximum oxidation state. If it is +6, yes, we can expect it to change for +7, but here is already +7, here it is +6, here it is +4. See, both times, like in both cases the number is decreased. Decreased means it is reduction only, not oxidation. So this is not the correct one. Okay, they are asking about which is showing disproportionation, A and B. So in the similarly here also, this is also not the disproportionation reaction, only A and B. So option 1 is correct. I hope it is clear, there is no confusion, right? Next, here this is from thermodynamics. See, work done formula. So isothermal condition at a particular temperature expands. So V1 is 0.1, V2 expands means volume should increase. So this much is the final value. Okay, against a constant pressure. P external is how much they mentioned? P external is 2 bar. Okay, now what is the work done by the gas they are asking? Work done by the gas, we can see the formula. W equals to P external dV. dV means change in volume. So this is what the formula we are taking now. W equals to minus. So how much it is mentioned? External pressure 2 bar, right, 2 bar into what is the dV, V2 minus V1, it means 0.25 minus 0.1 liter. So this is nothing but minus 2 into 0.15 liter bar. Yes, I hope it is clear, there is no confusion here, right? Okay, so this is how much, minus 0.30 liter bar. See here, options are not in liter bar, they are in joules, kilojoules or joules. So 1 liter bar equals to 100 joules. So what we can write? So I am replacing this liter bar with this joules. So what they mentioned, see here, 1 liter bar 100 joules. So they only given, so you can take that value. So 100 joules. So what it will be giving, minus, see 30, so 2 zeros are there, after decimal 2 numbers are there. So we can remove that and we can write minus 30 joules. So do we have any options like this? Yes, first option is there now. So you can choose option number 1. Think most of the questions are having first option only, right? No issues. So there is no nothing like a cheat codes or anything like this to follow here. So just you need to know purely concept. Don't follow any cheat codes or stupid things like that. Okay, just attempt only the questions that you know clearly. Okay, because there are negative marks in the exam, right? So don't go with some useless stupid things like cheat codes and all. Okay, so try to learn the concept and focus on the like known concepts only, or the known questions in the exam only. Okay, don't waste your times on unknown questions. Okay, next, which among the following is not a greenhouse gas? Yes, so these three, methane, ozone and nitrous oxide are greenhouse gases. Sulfur dioxide is not a greenhouse gas. So option 4 is correct for this question. Next, yes, how can we do this? For a cell reaction, this is the cell reaction they given. E0 cell is provided at particular temperature. They are asking about standard Gibbs free energy. So how can we do this? So delta G0 equals to what we can do? Delta G0 equals to, see there are two formulas now. Delta G0 equals to minus NF E0 cell, like this. And we can also have one more formula, delta G from equilibrium, delta G equals to, see this is the formula actually we have, delta G equals to delta G0 plus RT ln Q. So for an equilibrium reaction, we are saying delta G is 0. If it is 0, then delta G0 becomes what? Minus RT ln K. Q is reaction coefficient, K means equilibrium constant. So using these two equations, I am writing an equation here, minus NF E0 cell equals to minus RT ln Q. So what they are asking, wait, yeah, so directly, from this if they ask for E0 cell, we have to use this relation, or K if they ask, you have to use this relation. So here they are directly asking delta G0 na? So this equation is directly enough for this. Yes, so what we can say, delta G0 equals to minus, see N means how many electrons are changing here, see 2 plus 3 ions are converting into 2 plus 2 ions, it means 2 electrons are changing here. So N value here is 2, okay, 2, and F means Faraday we know 96,500 coulombs, right? Okay, and then next what we have here, we have E0 cell. What is the E0 cell value they mentioned? E0 cell value is 0.24 volt. Okay, we know 1 coulomb volt can be written as joule, right? Therefore if you simplify this, we will be getting around minus 46.32 like we will be getting, if you simplify this, 46320 coulomb volt. I can write coulomb volt as joule na, like this, but this kind of option is not there, so we will be getting 46.32 kilojoules we can write. So this is the answer for delta G0. Yes, so for this particular question, this is the explanation. See what we did, for a given cell, they are given E0 cell, they are asking about delta G0. So directly E0 cell delta G0, we have direct relation now, use that. Okay, Now my intention is not to explain this question itself, but not my intention. My intention is to give all the related questions, are the related formulas that we can expect questions, right? See we have one more relation like this from the thermodynamics, where for an equilibrium reaction delta G will be equals to 0, then we can modify this equation as delta G naught equals to minus RT ln K. Okay, from this can we make the relation like this? From this can we make a relation like this? Yes, we can make. Okay, or so this is one relation, just hold for some time. And one more here, so we have, if they ask for K, so what can we do? So K can be also calculated like this. Delta G naught is given, so they are asking for K. What you need to do? K equals to, see I am sending this minus there, minus delta G naught by RT, and if ln goes this side, it can be written as E. Like this you can write. Okay, see once again I am saying, if K value is given, equilibrium constant value is given, so you have to calculate delta G naught, use this formula. If delta G naught value is given at a particular temperature like 298 or something like that, use this formula to calculate K. Okay, so this formula you can use, and one more formula also we can have, that is what? K equals to minus delta G naught by 2.303 RT, 2.303 RT, this is a power to the 10. Okay, so here base 10 here we have, that is having log minus delta G naught by 2.303 RT. So this is one more formula. So these two formulas you can use to calculate the equilibrium constant. Again, if they ask for E naught cell, you have to use this equation. That is what we have, Nernst equation now. So what is the Nernst equation? We have E cell equals to E naught cell minus 0.059 by n log K. So this is the Nernst equation. See, I have brought all the important formulas that is required based on this particular chemical formula. I have brought all these things. What is K here? Equilibrium constant, concentration of products by concentration of reactant you should take. Next, the enzyme that utilize ATP in phosphate. Okay, so look here this question. So which alkaline metal is used as a cofactor here? So always remember that will be magnesium. So these, see, this kind of questions you can expect in NEET exam, because they are interlinking the chemistry part to the biology part, right? So it means this kind of questions, like wherever you have like about these receptors and all, so you can expect a question from that also, right? Okay, see now what is a suitable reagent? Yes, this is very easy question. No? So alkynes to cis alkenes. What is this? Alkynes to cis alkenes. What is the like reagent we will be using? We will be using like Lindlar's catalyst. What is the catalyst name for that? Alkynes converting into cis alkenes is Lindlar's catalyst. Lindlar's catalyst. Lindlar's catalyst. What is the formula of Lindlar's catalyst? H2PDC. They may give it as quinoline or barium sulfate, like that they will be giving, because it will be acting as a catalytic poison and stop the reaction after forming the alkene. If it is not used, alkane is formed. That's why we are using this quinoline to stop the reaction after forming this cis alkene. I hope it is clear. Now what if we use this one? If we use alkynes, if we use this, if we use this sodium in liquid ammonia, so what happens this for this reaction? So when we are using this, it will be producing trans alkenes. So it will be producing trans alkenes like this. So these trans alkenes, conversion of alkynes to trans alkenes is process is called Birch reduction or Birch reduction using alkali metal in the liquid ammonia. So alkali metals may be sodium, lithium, like that. Next, thermal stability. What happens? Thermal stability down the group for this oxide, thermal stability decreases. So the lower one is least stable and higher one is most stable. So what is the answer here we have? So yeah, so down the group it is decreasing, so it means water will be having more stability. So this is the correct one. Next, Here PB, which of the following is incorrect statement? See, PbF4, see, always remember PbF4 and SnF4 are ionic. What I am saying? They are ionic, but they mentioned it as covalent, which means this is incorrect. So you can choose option number 1 as of now and look for this silicon tetrachloride. So this can easily undergoes hydrolysis and forms a silicic acid like this, 4HCl. So here we are seeing silicic acid now. So after hydrolysis of SiCl4, it gives silicic acid. Now the question is like this. See, they will include CCl4 and SiCl4. Out of these two, which will undergoes hydrolysis? Only silicic acid will undergoes silicon tetrachloride will undergoes hydrolysis, but not CCl4. So since it is having vacant d orbital, it can accommodate the incoming water during this reaction, but there is no possibility for carbon because there is no d orbital and the reaction won't proceed and CCl4 won't undergo hydrolysis. Okay, only silicon tetrachloride will show that hydrolysis reaction. I hope it is clear. Option for this question is, the incorrect one is PbF4, which is ionic, but they mention it as covalent. Next, yes, this is also important method. So pure nitrogen comes from the metal azides like sodium azide, barium azide will be giving pure nitrogen. Okay, Haber's process is for synthesis of ammonia. What? Haber's process is synthesis of ammonia. Contact process is for preparation of sulfuric acid. Decone's method is for chlorine. So based on that you can choose the option A4. A4 here only we have, and the next B3, that's it, over. Contact process sulfuric acid. So option number 4. Even by knowing one option we got the answer for this question. So don't waste too much time when you have direct answers like this. Okay. Which of the following diatomic molecular species have only pi bonds? Yes, just write the order like sigma 1s, sigma 2s, like that we will be writing the molecular orbital. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma star 2s, then next pi 2p x equals to pi 2p y we are writing, then next sigma 2p z we are writing. Now we have to write respect to anti-bonding also. This is enough as of now. So because I will be explaining direct for direct one. Okay. See, whenever total electrons are less than 14, we have to follow this. If the electrons total count is less than 14, if it is less than 14, we have to follow this. Okay. After this, what we have? Pi star 2px, the next pi star 2py, next is sigma star 2pz. This is the order we have. Okay, guys. Now I have made a clear-cut explanation, like you won't miss any question if they ask from molecular orbital theory. If you watch my lecture on this molecular orbital theory, which is there in the channel with named as MOT, chemical bonding 3. Again, you can also watch it for valency like VSPR theory also, where I have made most effectively by using the PYQs only. So you can access complete chemical bonding videos from that playlist and you can watch it and you can learn some important topics from that will be definitely helpful. So as of now, use this and fill the electrons. See, they are asking only pi bonds are present. Okay, I will be doing for this too because I know direct answer will be there here. I will tell you why I am doing this. See, for beryllium, atomic number is 4, 2 atoms are there, so it means 8 electrons are there. So 8 means 2 here, 2 here, cancel out, bonding, anti-bonding, cancel out, 2 here, 2 here, how many over? 2, 4, 6, 8, 8 over, cancel out, cancel out, cancel out, cancel out. So bond order will be what? If bonding and anti-bonding containing same number of electrons, so bond order will become 0. What is the bond order formula we have? Number of half into number of bonding molecular orbital electrons minus anti-bonding molecular orbital electrons. This is the formula we are using now. So that will become 0 for this. Now for C2, we know for each carbon 6, 2 carbons are there, 6 plus 6, 12 electrons. See, till here 8 over, 9, 10, 11, 12. It means we need to follow Hund's rule here, 1, 1, 1, 1, like that. How many over? 12 over now. up to here 9, 8, 10, 12. Yes, 12 over. See, up to here they are cancelling out each other. Now we will be having electrons only in pi orbitals. It means the how many pi how many electrons are there in bonding molecular orbital here? So here 4 are there, anti-bonding 0 we can say by after doing this cancellation, or you can take like this. How many bonding electrons are there? 2, 4, 8. 8 minus anti-bonding 2 plus 2, 4. So how many we are remaining with? 4 by 2. So it means 2, bond order is 2. It means between 2 carbon atoms we have 2 bonds like this, and these bonds are completely made up of pi orbital electrons only. So these are pi bonds only, there is no sigma bond here, right? So the option for this question is C2. I hope it is clear. Now they will ask for magnetic nature also. If any electron is unpaired is present, then we can say it is paramagnetic, but all the electrons are paired, so it is diamagnetic. So my question is for calculate it for B2 C2 over na. So I am asking for B2. You can do it for this question, and in the comment box you can mention question number 59 B2, what is the bond order, and its magnetic nature. You can mention in the comment box for this, because this is also important one. So for C2 you have to use another orbital energy diagram. So first write sigma bond, then write pi orbitals, then you will get the proper answer. So C2 bond order will be 2, there is one sigma and one pi bond. For N2 we will be getting one sigma and 2 pi bonds. I hope it is clear. And O2 is paramagnetic, N2 is diamagnetic, and C2 is also diamagnetic. Okay, I asked for B2. So for this particular question option number 3 is correct, because we got the 2 bonds are pi bonds only. Okay, now give a try for this. This is very easy question, right? So just try from your side. Yes. For the second period elements, the correct increasing order of ionization enthalpy. What are the second period elements? We have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, right? So always remember, ionization energy is highest for noble gases, then fluorine, I mean electronegative atom. After this, when we compare oxygen and nitrogen, since nitrogen is having half filled electronic configuration, the energy required to remove the electron from nitrogen will be more than the oxygen. Therefore after fluorine we have nitrogen, and the next oxygen. Okay, after this we have carbon and boron. So carbon will be more than the boron. When it comes to boron and beryllium, since the beryllium is having 2s2 configuration and boron is having 2s2 2p1 configuration, it is easier to remove electron from 2p1 orbital than this 2s2 orbital, because of this closeness towards the nucleus. The 2s orbital is very closer towards the nucleus, therefore it is having like a high tendency towards the nucleus. It means the positive charge will be acting on this s orbital electrons more effectively than this p orbital, therefore it requires more energy. So this concept is called penetrating capacity of this s orbital is more than the p orbital. That's why beryllium is having more ionization energy than the boron, and least is for lithium. Like this you need to answer. So which option is correct? Correct here? See, here it is given. Yes, fourth option is correct. Check. No, fourth option, no, not the fourth option. Once again cross check with this. The option 1 is having similar order to this. No, oxygen, carbon, beryllium. Yes, second option is correct. Okay, so if you want to learn this concept little more clearly, or if you want to know about periodic table and its properties completely, so just go to the playlist and search NEET World. Just look in the playlist, or you can go to the YouTube and search NEET World and the next periodic table by Ajay Sir. So you will be getting my videos, I mean whatever the videos I made on this. So there will be the proper lectures on this ionization enthalpies and electron affinities, all those things I made for the NEET and EAPCET especially. Okay, including the PYQs are included there. Okay, so what is a biodegradable polymer here? So only nylon 2, nylon 6 is a biodegradable polymer in the given options, right? Next, here the pH of saturated solution of CaOH twice is, pH is given 9. Okay, now they are asking about solubility product. Yes guys, this is one of the important question. We may expect questions from solubility product, KSP and its solubility for sparingly soluble salt or this kind of solutions. Okay, now let us make it very clear with me. See, whenever we have this CaOH twice, so in the solution we know this is basic compound, so it will dissociate like this now. Saturated solution. So saturated means there exists an equilibrium between dissociated ions and undissociated molecule like this. See how many OH ions will liberated by here, by this molecule, it will be 2 OH minus. Okay. Now if the pH is this much, what about POH? This is, see, at 25 degrees Celsius, pH plus POH equals to 14, right? Then POH equals to 14 minus pH, that is 14 minus 9 gives 5. If POH is 5, we know POH equals to minus log concentration of OH minus. So this is nothing but we will be getting OH minus concentration as 10 power minus 5. I hope it is clear. There is no confusion from this. Okay. Now look here. See, initially this is a like compound we have, basic compound we have, dissociates like this. Now let us say at the saturated point, when I am saying KSV solubility product of this compound, I should talk about at the saturated solution. Okay. Now let us say this is a S amount of substance we have taken and it will be having 0 solubility at a time 0 seconds. After some time, when the T equilibrium is reached, so the some quantity of this substance will be dissociated like this. Let us say from that S amount is converted like this, and here it is having 2 into, see, 2 ions are coming now, so I am taking it as 2S. Okay. So here actually we should write it as S minus S alpha. This is S alpha, this is 2S alpha. See, this is a strong electrolyte. The dissociation is maximum, that is alpha value will be equals to 1. So S into 1 becomes what? S into alpha is 1. So 1 minus 1, it will be 0. That is how we need to take. So this S alpha is nothing but S only, because alpha value is 1 I am saying. This is 2S. I hope it is clear. Now directly find here. So 2S is this much. Okay, 2S we got like this. Now see, what is the value of 2S here? 2S value is 10 power minus 5, because complete OH minus ion concentration is 10 power minus 5 in the solution. That's why I am writing 2S equals to 10 power minus 5. So then S will be 1 by 2 into 10 power minus 5. So this is how you need to write. Okay. Then next, find KSP. How can we write this KSP? What is the ion we have? Ca plus 2 and OH minus. Na? So how do we write this? Write the cation and whatever the coefficient is there here, write it as a power of that particular ion. Here write the anion. What is the coefficient here? We have 2. Now what is the value of S? Calcium plus 1. So calcium is having S and this is having 2S. So what here I should write S, this is as 2S whole square. Why I am writing S and 2S? Because these are the values for them. Okay. So in terms of solubility, so I am writing 4S cube. Okay, 4S cube. Why I written S, this 2 square 4, S square and S, so S cube. So next here we have 4 into, what is the S value? 1 by 2 into 10 power minus 5 whole cube. Okay. So this one can be written as 4 into, see, 1 by S cube, it means 1 by 2 square into 2 into 10 power minus 3, 5 3 is 15, minus 15 I am writing. So 2 square 4 and this 4 cancel, 1 by 2 means 0.5 into 10 power minus 15. This is the KSP value. Okay, this is how we need to calculate. I hope it is clear, there is no confusion. So KSP is how much? 0.5 into 10 power minus 15, again first option. Okay, I hope it is clear, no confusions. Next, see, rate constant they are saying. If the rate constant for first order reaction is K, the time T required for completion of T 99%. See, what is the formula we have for rate of a reaction for first order? T equals to 1 by K ln A by A minus X. A means for initially concentration, A minus X after some time T. Okay, so they are saying T 99%. So rate constant for the first order. No? So K equals to 1 by, see, they are asking about T in terms of T. So I can write T equals to 1 by K ln. So ln also we can write in terms of log as 2.303 times log. Ln can be written as 2.303 times log K. So what is the A here I am taking? That is, let us say 100% initially. So A minus X, 100 minus how much it is completed? 99%. So it means what we are remaining with? So we are remaining with 1. So 100 minus 99, 1. So we can write like this. So T can be 2.303 by K. See, log 100 means 10 power 2, can I write? Yes, we can write. So it can be 2.303 into log into 10 power 2 means I can write log 2, I can write, if it is log A power B, I can write B log A in this format. So that is what I am doing here. So we will get log 10 by K. So log 10 value is 1. So 2.303 into 2 will be 4.606 by K, which is equals to T. So this kind of option, do we have any option like this? 4.606 by K. So option number 3 is correct. I hope it is clear, no confusion. So if they ask for T 50%, how can we do? So we will get, if we solve like this for T 50%, so T 50% will get 1 by K into 0.693 by K. This will be the T 50% completion for first order. Okay, they are asking about 99, so you have to go with this. T 50% means time required for 50% completion will be like this. So non-essential amino acids from the following. Okay, so I will tell you one trick. So essential, non-essential amino acids, how we will be remembering? So you can follow this trick. See, there are different amino acids. Now, out of that, you use this word Hal, Vim, PTT. So these are the essential amino acids. What I am saying? These are the essential amino acid like histidine, arginine, leucine, lysine. These are the what? Essential amino acids like valine, isoleucine, methionine, like that. So here out of this, now compare here like tryptophan, threonine, and the next phenylalanine. So these are the what? Essential amino acids. So here consider here valine, yes, valine is there, so it is essential, so write it as essential. And the next, the non-essential amino acids they are asking. Here I told you leucine, essential, and here I told you arginine, but here they given alanine. So yes, this is non-essential amino acid. Here I told you lysine and leucine are essential. So these three are essential, this is non-essential. I hope it is clear, there is no confusion. So you can say alanine is the non-essential amino acid, but arginine is essential amino acid, you can remember. I hope there is no confusion. What is the trick word? What is the code word I told you for essential amino acids? Hal, Vim, PTT. Okay. For non-essential amino acids, you can say AAA, triple G, SPYC. So this is for what? Non-essential amino acid. So this is what I have made this trick. Okay. So you can search what is this AAA, triple G, the amino acid list, and you can like try to remember them. Okay. At least remember one part. You can remember this essential amino acid, that will be helpful. Okay. That's enough also. Okay. If there is not in this list, then you can consider them as non-essential amino acids. I hope it is clear, no confusion. Next. Among the following, the reaction that proceeds through electrophilic substitution. Okay, so electrophilic substitution means one electrophile should be replaced by another electrophile, right? Okay, look here. Here it is going as N2 is going out, but it is taking these electrons. It means it is removed as nucleophile. Therefore, Cl minus is incoming. So I can say this first reaction is nucleophilic substitution reaction. Aromatic nucleophilic substitution reaction mechanism is followed here. In the second case, see AlCl3 is there and Cl2. So when AlCl3 and Cl2 is reacting, they will generate Cl plus ion. So this is the electrophile. So this electrophile is substituted on benzene ring. See the product side, it means one of the hydrogen removed as H plus, which is electrophile, and replaced by this Cl plus. Therefore option 2 is correct, which is electrophilic substitution. Now here this is what, see all the pi bonds are removed and chlorines are added. So just it is an addition reaction. Okay, but they are asking about electrophilic substitution. So second option is the most appropriate. First is for nucleophilic substitution. Third one is for addition reaction. And fourth one, see here OH H2O is removed, Cl minus. Yes, Cl minus is incoming now. So that is Cl minus. That is nucleophilic substitution. So this is nucleophilic substitution. This is aromatic nucleophilic substitution. This is aromatic electrophilic substitution reaction. So second option is the most appropriate answer for this particular question. Yes. So which mixture? The mixture that forms maximum boiling azeotropes. Always remember, negatively, see we have ideal solution and non-ideal solution. So these non-ideal solutions forms shows two types of deviation. One is positive, another one is negative deviation. Those solutions which are showing negative deviation forms maximum boiling azeotropic mixture, maximum boiling azeotropic mixtures. Okay, maximum boiling azeotropes shown by negative deviation, deviating non-ideal solution. Positive will be forms minimum boiling azeotropes. Okay, so here how do we identify positive deviation and negative deviation, ideal and non-ideal? See the solutions, for example, if A and B are mixed, if AB components are mixed in order to form a solution of AB type, this is the AB solution. If A and B are having similar intermolecular forces, what I am saying, intermolecular forces are almost same. For example, benzene, toluene I have taken, almost they are having similar intermolecular forces. When we mix that when we mix these two components, it will form ideal solution. Okay, now for example, I have a compound which is having acidic nature and another one is having basic nature. One is having acidic nature, another having basic nature. So what happens? They will be having attractive interactions now. So what happens when they have attractive interactions? When they have attractive interaction, they will show negative deviation. What I am saying? They will show negative deviation. When acid and base is mixed, they will the intermolecular forces between AB is more than the AA and BB. Therefore, this AB will be showing negative deviation and forming maximum boiling azeotropes. See here, heptane, octane having similar nature, so they will be ideal solution. They won't form these azeotropes. Now acetone, carbon disulfide, this will be forming positive deviation. Okay, ethanol, water, this is also forming positive deviation. Water, nitric acid shows, see between them hydrogen bonding is there now. So due to the hydrogen bonding, they will attractive interactions increases, therefore shows negative deviation, forms maximum boiling azeotropes. I hope it is clear. Next step, for a chemical reaction, yes, this is the chemical reaction given. How can we write the expression, rate expression? So when we are writing rate expression for this, so just use this reactants converting to products now. So concentration of reactants decreases. So what I can write, N2, change in the concentration of N2 with time, okay, decreasing now, so use the symbol minus because it is reactant side, concentration is decreasing, so use negative. If there is any coefficient, write here in the fractions, okay. Here 1/3 is there na, you should write minus 1/3 dH2 by dt equals to, here product is forming plus 1/2 dN2 NH3 by dt. This is how you need to write. So based on this, just identify identify, yes, first option is only now, see, between H2 and NH3 we can write the relation like that, yes, that is the only one, yes, this is there, but here it should be 1/2, it is not 2, this is incorrect, and this is also incorrect, this is also incorrect, so first option is correct. So this is very simple, N2 plus 3H2 gives rise to 2 NH3, we are writing now, Haber's process, equilibrium symbol you can write, okay. Now the number of moles of hydrogen molecule required to produce 20 moles of, see, for 2 moles we require 3 moles of hydrogen, for 20 moles we require 30 moles of hydrogen, that's it. For like for nitrogen, you tell me, for every 2 moles of ammonia we require 1 mole of nitrogen, for every 20 moles of nitrogen we require, see, just multiply with 10, that's it, 10 moles of nitrogen is required. They are asking about 20 moles of ammonia, for 20 moles how many moles of hydrogen is required, yes, 30 moles is required, so go with option number 3. Hope it is clear. Which of the following compound is most difficult to protonate, yes, look here, there are lone pair electrons here on phenol, so we have lone pair electrons on phenol like this. So if, see, remaining things are water only, I mean first option is water and second option is methyl alcohol. So these are protonated easily when we compare with the phenol because it will becomes like this. But these lone pair electrons of phenol is in conjugation with the ring pi electrons, and it is now less available to accept this proton. But when we discuss here the aliphatic alcohols or oxygen, lone pair electron or oxygen are freely available here to accept this H plus ion, but here these are participating in the conjugation, therefore these are less available. So it is very difficult to protonate the less available lone pair electrons when we compare with this freely available lone pair electrons. So it is possible easily protonated in this case and in this case and in this case, but not here because the lone pair electrons are involving in the conjugation in this phenyl ring, this benzene ring, phenyl ring, therefore they are less available, more difficult to protonate. So option 4 is the most correct answer. I hope it is clear. Next, for ideal solution, the correct options are, see, I told you ideal, non-ideal solution, non-ideal solutions again negative, positive deviation. For ideal solution, so delta S mix, the entropy for whatever the solution, the ideal solution, if I say entropy, delta change in entropy will be always positive, okay, and delta G mix will be always negative, and delta H mix, this will be delta H mix will be equals to 0, okay, and delta so delta V mix also 0. For ideal solutions, these are the conditions. See whether it is ideal, yeah. So for ideal solution, what I am saying, see, delta G will be always negative, whether ideal, non-ideal, anywhere, okay. Now delta G mix will be different for ideal and non-ideal. See, for ideal solution is always 0. For non-ideal solution, for negative deviation it will be less than, and for positive deviation it is more than. So even more than 0 I am saying. So delta V mix also for ideal solution it is 0. For non-ideal solutions it will varies. For negative deviation, atoms comes close now. So what happens to the volume? Volume decreases. It means it will lesser than the negative. Delta V mix will be negative. For negative deviation, it will be delta V mix will be delta V mix will be less than 0, I am writing. So for positive deviation, delta expansion takes place, therefore delta V mix will be greater than 0. For ideal, it will be 0. So look here, they are saying correct option. So for ideal solution, delta H mix will be 0, enthalpy change will be 0. Okay. Always remember, conjugate acid bases are differ in their H plus ion. For example, I have A, okay, its conjugate, for example, okay, let me write here. I have HA, let us say. So this is the substance. If I say the conjugate base of this molecule will be A minus, the conjugate acid of this molecule will be H2A. This is what? Conjugate acid. This is what? Conjugate base of this molecule. So how this one and this one are differ? By one proton. Here one proton is less, here it is more. And how these are differ? These are also differ one by proton. So now the Bronsted acids of water. So if H2O is the molecule, its Bronsted acid should have, acid means one proton more, H3O plus. This is the Bronsted acid. Okay. Now, so H3O plus, it is there in the option number 2 and option number 4. Now for HF also they are asking about Bronsted acid. So Bronsted acid means again one H plus should be added, so it will become H2F plus. So it is here. So this one. So if they ask for Bronsted, if they ask for conjugate base, if they ask, see, if they ask, these are Bronsted acids. These are what? Bronsted acids are conjugate acids of these molecules. What they are asking? See, I haven't seen the question properly. Now let us read the question. Okay. Whatever the concept I explained, that is correct only, but not exactly for this question. Okay. Concept is correct. Okay. I will explain this question now. See, see, conjugate base for the Bronsted acids. See, H2O is one acid. They are saying HF is also one more Bronsted acid. They are saying. They are asking about the conjugate base of this. Conjugate base means what? It should release one H plus, and the remaining negative part is there, na? That is its conjugate base. So this negative part is the conjugate base of this acid. Okay. And what is the negative part here also? What are the negative part here? H plus, F minus. So F minus is the conjugate base of this acid. So OH minus, F minus are the conjugate bases of these two molecules. Therefore H minus, OH minus and F minus. So option 3 is correct. I hope there is no confusions. It's clear now? Always remember, like conjugate base, acid bases are differ by H plus ion. That's it. So narrow spectrum. So narrow spectrum antibiotics is what? This penicillin G, and remaining are broad spectrum antibiotics. Okay. These are the static or standard questions. I mean, just by reading the answer, I mean questions, we can get this. Okay. Reading the topic, we can answer those. Okay. This ozone, again A is there. A is an alkene, he is saying. Okay. Reaction with ozone in zinc and water, we will be getting a product. What the product they are saying? Propanone. So this is a propanone and ethanol. Ethanol means it is like this. Okay. In equimolar mixture. Okay. Right. Addition of HBr to alkene A gives B. Okay. The major product as major product. Arrange the structure of major product B is what they are asking. So in order to solve this question, we need to know what is A here. So it is easy now. Ozonolysis is nothing but alkenes upon ozonolysis gives carbonyl compounds. So how can we do? Whenever we have a double bond like this on ozonolysis, so what we need to make is just break this double bond and write the products like this. Keep one oxygen here and one oxygen here. That is our product. So apply the retro process here. Use these two things and find A here. See, if I am writing it like this, and here also I am writing HCH3O, like this it is there, na? So go back from here. So remove these two oxygens. What is the alkene we can expect there? So the alkene we can expect here is like this carbon directly attached to this carbon, and here it is having hydrogen, here it is having methyl, okay, and this side methyl, this side methyl. So this is our A. I hope it is clear. Very simple. Ozonolysis back process, retro process we can say. Okay. Next. To this, what I can add? HBr I need to add. So this is unsymmetrical alkene. Just follow Markovnikov rule. What is that Markovnikov rule? The negative part of this adding molecule, the negative part of this HBr is added to least number of hydrogen containing carbon. So here it is having 0 hydrogens on this carbon. Here it is having 1 hydrogen. So where do we need to add? The least number of hydrogens are on this carbon. So there you need to add bromine. Here you need to add hydrogen. That's it. So look for the answer. If it is HCl means you can add HCl only. If it is HBr, you can add HBr. If it is HCl, you can add HCl. So here it is HCl they mentioned. So Cl here, H here. So which option is there like that? See, option number 3. 1, 2, yes, this is the option. Okay, I hope it is clear. No confusions, right? Okay, then next solve this. the correct electronic configuration of central atom in K4FeCN6. So first of all, this is a complex na, KFeCN 6 times, like this we have now. So Fe, what is the oxidation state? K4, it is like this. Find the oxidation state of iron here. So how can we find? See, the cationic sphere, this is cationic sphere, this is anionic sphere. So we have 4 cations, 4K plus. It means what is the charge on anionic sphere? It is FeCN6 4 minus, like this also you can understand. Okay. Now either you can do like this or directly find the oxidation state of central metal atom as considering it as neutral. Now here it is X, let us say, and cyanide ions are 6 are there, each one minus 1 charge, Cn minus, which is equals to minus 4. Okay. So X will be plus 2. This is the oxidation state of iron. Okay. This is done. Okay. Now iron, see Fe, iron, right, atomic number is 26. What is the oxidation state we got here? Plus 2. So when atomic, see for iron it is 26 now. Simply you can write 3d6 26 now. So 3d6, see here I will be telling you the trick to remember the electronic configuration also, very easy. See, what are the orbital valency orbitals we have? 4s 3d. See, you write 6 here, 3d6, here 4s2, that's it. 26 3d6 4s2, that's it. Okay, 4s2 3d6 you can remember. Now you have to remove electrons from the highest nth level. It means you need to remove the electrons from here because it is having plus 2 oxidation state. So it will becomes what? This is in Fe0 oxidation state, but we require in plus 2 oxidation state now. Remove from highest energy level, nth level. So it will becomes what? Fe plus 2 means 3d6 4s0, like this. Okay. Now see, the cyanide ions are strong field ligands. What I am saying, cyanide ions are strong field ligands. So these electrons, these orbital electrons will be when this metal atom is placed in the ligand field. What I am saying, when this metal atom is placed in the ligand field, so the d orbital degeneracy is lifted like this, like this. Okay, how many electrons are there? 6 now. 1, 2, 3, 4, 5, 6, like this. Again, when this octahedral complex, 6 ligands are there, so octahedral complex I can say. So in this case, the d orbitals will be split into 2 energy levels, like T2g energy level and Eg energy level, and T2g energy level and Eg energy level. And here the orbitals which are in between the axis, what I am saying, the orbitals which are in between the axis are in the lower energy, and orbitals which are along the axis. What are the d orbitals we have? One is dxy, dxz, dyz, and this is dx square y square, dz square. So out of these, the orbitals which are along the axis will experience more repulsions. Therefore, the energy of those orbitals will be lifted. So the energy of those orbitals is higher energy and the remaining are lower energy. Okay, these are in between the axis, so that's why they are in the lower energy. Now since I told this Fe plus Cn minus is strong field ligand, Sn minus is strong field ligand, the splitting is maximum. So when the splitting is very high, the electron filling, these 6 electrons are filled only in the lower energy like this. It means the down state is T2G set, upper state is EG set. So we have the electronic configuration T2G6, EG0. So it is, there is no unpaired electron, so I am saying it is diamagnetic. So which is a proper electronic configuration here, T2G6, EG0, like that we should answer. This is what the crystal field, CFT, crystal field theory. Next, identify the statement. See, PCl5 is having trigonal bipyramidal geometry, TBP we can write. Okay. In this, 2 chlorine atoms are along the axis and 3 are in between the axis like this, right? Okay. So these chlorine atoms which are in the trigonal bipyramidal, trigonal planar geometry are equatorial. What I am saying, equatorial, and 2 are along the axis like this. So these are axial. Okay. Now 3 equatorial PCl5 bonds make angle 120. Yes. What is the angle here? 120. Okay, that is correct. The 2 axial makes the angle 180 to each other. Yes, this is 180. That is also correct. Now the axial bonds are longer than the equatorial. Yeah. So the bonds which are along the axis, the 2 bonds above and below are along the axis. Those are having more distance, more longer distance than these equatorial bonds. And the axial bonds are now having, what I am saying, longer distance. So those bonds are weaker bonds, easily dissociates and decomposes. When PCl5 heated, it will decomposes like PCl3 and Cl2. So PCl5 molecule is non-reactive. No, it is reactive and it will decomposes like this. I hope it is clear. Okay. Next, how to make a buffer solution? So buffer solution is a solution which resists the change in pH when we add small amount of acid or base to that solution, right? Okay. So now in order to make a buffer, there should be strong, see, there should be a combination of weak acid, salt of weak acid plus strong base and plus weak acid. So these should be the combination for acidic buffer, and basic buffer also salt of weak base plus strong acid plus weak base. Okay. Now in order to make this, see, weak acid here we are seeing, here we are seeing. Na? So quantity of weak acid should be taken more than the strong base, then the resulting solution will be forming a acidic buffer. Resulting solution will be forming a acidic buffer. So here 50 ml NaOH, 25 ml, no. What I told you, weak acid quantity will be more. Okay. See, 100 ml 0.1. So how much it is? 10 millimoles. Here it is, this is also 10 millimoles, equal quantity. No, we'll ignore that. Here 100 ml 0.1, and here, yes, look here, we have, this is a basic buffer, see, 100 0.1. So 0.1 into 10 ml. So this will give 100 means 10 millimole acid, strong acid is given, HCl, plus 200 ml into 0.1 molar base is given. This is what? 20 millimole of weak base is given. So quantity of weak base is greater than strong acid. So this will results to form a basic buffer. So this is correct, which will be resulting a basic buffer. Other options are not forming. So this is about acidic buffer, this is about basic buffer. I hope it is clear. So option 3 is correct. So you can see here, strong acid, strong base won't form a buffer. Okay. So I hope the explanation is clear. Yes. Then try this question. So try this question, easy question. See, so whenever we have something like this, so just heat this substance, ammonia is there, I am writing like this. See, here it will be removed 2 hydrogens and 2 water, like OH, 2 OH from here and 2 hydrogens from here removed as water. So dehydration takes place and forms a compound like this. So do we have any options like that? Yes, option number 2, that is the correct one for this. Next, yeah, again valence shell electron pair repulsion theory, one of the most important and the most like interesting important topic that no one should like skip this topic if you are really wanted to score good score in the exam, and if you want to not miss marks from chemical bonding, means you should cover this valence shell electron pair repulsion theory and MOT, both of these. At any cost you need to finish these 2 topics. Okay, next XeF4. So how can we do? Xenon 8th group element, 18th group, so I am taking valence electrons 8, surrounding atoms 4, it is by 2, we can take like this. So what is the general formula I am giving here? So hybridization number or steric number equals to group number or number of valence electrons plus number of monovalent atoms. If there is a anionic form, if the compound is anionic form, right, plus A. If it is cationic form, minus C by 2. A means charge of anion, C means charge on cation, like that. So there is no charges, so 0, 8 plus 4 by 2, this is how much? 12 by 2, that is 6. 6 means sp3 dehybridization, sp3 d2 hybridization. So 6 orbitals are there, out of that 4 bonds are there, 4 surrounding atoms, it means 4 sigma bonds, so 4 bond pair electrons, 2 lone pair electrons, octahedral geometry with 4 bond pairs. So xenon like this, and here one lone pair, here one lone pair, that's it. So square planar it is. So for this distorted octahedral, for this it will be square pyramidal, for this it will be pyramidal, like that you need to answer. So choose the option which is having this kind of option, answers from the given 4 options. Manganate, permanganate ions are tetrahedral due to, yes, they will form pi bond involving d orbital of manganese and p orbital of oxygen, involves p orbital of oxygen, d orbital of manganese, that's it. Okay, not stable. See, silicon fluoride, yes, silicon is smaller size, that can be stabilized, but when it comes to silicon hexafluoride, fluoride is having smaller size, it can be stabilized, but the silicon here having hexachlorides, so this chloride is having larger size, it cannot accommodate on the small size silicon having larger 6 chloride ions, there will be repulsions, therefore this is not stable. So you can directly choose for option 4. Next, this is simple, already I told you the equilibrium constant, there I have explained everything related to how to use E0 cell, delta G, equilibrium constant, you can apply here. So what I told you there, K equals to, otherwise I will tell you once again, look here. So delta G0 equals to minus NF E0 cell, which is equals to, minus NR T ln K. These are the 2 equations we have. So using these 2, we can relate E0 cell and K. I hope it is clear. Okay. So what they are asking, equilibrium constant, K they are asking. So how can we find that? So N I am removing. So sorry, here it is RT only, not NRT. This is RT minus RT. So here minus, here minus, here minus I am removing. So writing the remaining part. So NF by RT. Here we have E0 cell. Okay, this is what the part we have. Here we have K equals to, so here I can write 2. I will make it more clear. NF E0 cell equals to RT ln K. So I want K now, so I am writing in terms of log. So how can we write in the form of log? 3.03 log K, we can write like this. I want this K, it means what I can do, remaining things you can send this side, NF by E naught cell by, what are the remaining things, 2.303 RT, right, okay. So K equals to log K, so K I am keeping here only, I am writing 10 here. So this is what the equation you can use, okay. So now look here, they mentioned at 298 Kelvin, so this will be the value, this will be the value of 2.303 RT by F. So I can say, so here K equals to, I can write directly, 10 to the power 0.059 E naught cell by 0.059, like this we can write, okay. So K equals to 10 to the power, this is how much they mentioned in the question, 0.59, here denominator it is 0.059. So how much we are getting, this is 10 times now, so 10 times means finally what we are getting here, K equals to 10 to the power 10, this will be the answer. So here see 1 into 10 power 10 is there, so that will be the answer. I hope it is clear, okay. So even if you forgot the concept, formula, just go with the concept. If you really stick to the concept, that will never make you to the wrong, okay, because that will definitely give you some kind of idea to approach the questions. So always believe in concept, not in the tricks or not in the mnemonics or not in the any stupid cheat codes, okay. So always try to learn the concept, from there also you can bring the formulas, okay. First of all, try to remember the formulas. If you forgot the formulas, don't panic, just go through the basic, whatever you know, from that you extract the formula if it is necessary, from that you can solve the question like this. Then next, amphoteric oxide, yes. So these are what, second group alkaline earth metals now, like calcium, magnesium, this one, beryllium, magnesium, calcium, strontium, barium, radium, all these are what, second group elements, okay. So out of this, beryllium forms amphoteric oxides and amphoteric hydroxides, so fourth option is correct, okay. Remaining will be forming basic oxides and hydroxides. So entropy is negative. So if the process, for example, reactants to product, this conversion, if number of gaseous particles are increasing, that is what, delta Ng is greater than 0, delta S will be positive. What is that? Delta S will be positive. If the gases are expanding or liquid is converting into gas, okay, here also delta S is positive. If solid is converting into liquid or liquid is converting into gas, so number of randomness in the particles increases, therefore delta S will be greater than 0, positive. So evaporation of water, liquid converting into gas, this is correct, this is what, positive, but they are asking about negative, no, this is positive. Expansion of gas at constant, expansion means randomness increasing, this is also incorrect. Sublimation of gas to solid, solid to gas, what is this, randomness increasing only, no? So entropy increases here also. See here atoms, two atoms, separated atoms are forming a systematic manner, forming a particular shape, particular molecule. So it means randomness here decreases, so fourth option, entropy decreasing. Okay. Now the spectral lines, transition lines falls in the visible spectrum, Lyman, Balmer. So for Balmer series, the visible region is for Balmer series. For Lyman it is UV, and for patch and bracket all these are IR. Okay, this is also very important now. Okay, for nth level to first level, any nth level to, if the transition is for first level, this is Lyman series, for appears in the UV region. For nth level to second level, what is this, Balmer series. Nth level to third level, Paschen, like that you should remember. Temporary hardness of water is removed by which method? So that will be removed by Clerk's method, where we will be using soda, calcium hydroxide. Okay, this is what lime we are using. In Colgan's method, we will be using sodium hexametaphosphate. What is that? Sodium metahexaphosphate. Yeah. Yeah, so we will be using sodium hexametaphosphate. Yes. So, but what they are asking to remove the temporary hardness. Yeah. So, Clark's method is preferred. Okay. So, ion exchange method, synthetic resin methods are advanced method than these two methods. Okay. So, yeah. So, to remove both permanent and temporary hardness, we will be using ion exchange method and synthetic resin method. This is more advanced techniques than these two methods. Okay. So, in the Clark's process, what is the chemical substance we are using? Calcium hydroxide. Okay. So, this will remove the what the temporary hardness causing substances are what? Bicarbonates of calcium and bicarbonates of magnesium. These are the two substances which causes temporary hardness, that will be removed by this calcium hydroxide in Clark's method. I hope it is clear. Okay. So, colgons, the name itself saying that calcium gone. So, the salts of calcium is removed in this colgons process. So, it is what? Sodium hexametaphosphate is used in the colgons process. I hope it is clear. Okay. The option for this will be B. Okay. Temporary hardness is removed only by Clark's method. So, here malachite green or malachite, okay sir, malachite is what? This is the chemical formula, CuCO3 dot CuOH twice. Okay, we will be studying about this in the metallurgy, right? Okay. Now, the basic nature. So, here whenever the amines are given, see, we have different amines, primary amine, secondary amine, tertiary amine is given. Out of this, they are methyl groups. Whenever we have methyl groups, see, they are asking about the basic nature in the aqueous solutions. Na? In the gaseous forms, if they ask, blindly go with this order, all the time you can follow this. But in aqueous form, the basic nature depends upon plus I groups and also what? Hydrogen bonding. So, these two effects should be considered. By considering these two, we will be having 2 degree first, then next, see 2 degree, where is the 2 degree? Yeah, 2 degree is more basic. Yes, yeah. First option we have, and the next 2 degree, 1 degree amine, the next 3 degree amine. So, 2 degree, 3 degree, only first option is there. So, there is no confusion, 2 degree, 1 degree and 3 degree. This is for methyl amines, okay, methyl amines. When we have ethyl group, when we have ethyl amines are there, the order will be 2, 3, 1, okay. So, these are the two different orders you should remember, okay, important, okay. Methyl group means 2, 1, 3, ethyl means 2, 3, 1, okay. What are the factors here we need to take? Plus I effect of alkyl groups, hydrogen bonding in the with the aqueous form after forming its conjugate acid from the base, okay. So, this is about the 2019 complete chemistry questions, okay. Now, if you are having any difficulties in solving this kind of questions, write in the comment box. We will be discussing about those questions in the upcoming sessions, okay. So, if you want any particular topic, write in the comment box, we will be discuss, okay. So, any difficulties are there, please feel free to reach us. We will always there for your preparation, and we will be there in your complete process of this preparation towards your exam, okay. So, thank you for watching. Happy learning.